Hello everyone, and welcome to our Part 1 video for our Module 6 lecture. In this video, we're going to be going over the fundamentals of t-tests, so we'll figure out when it's appropriate to run a t-test, the different assumptions we would have to meet to run a t-test, and the null hypothesis, as well as how we would calculate an effect size. The rest of the SPSS procedures on actually running a t-test in SPSS will be in our Part 2 video, so you can use that video to supplement the activities if it helps you out in understanding how the output works. Let's first come back to our decision tree that we've looked at in the past couple of weeks. The past 2 weeks we've done correlations and regressions, which both dealt with a parametric independent and dependent variable. So when we wanted to look at the relationship between variables, we would use a correlation. And then when we wanted to predict a certain dependent variable outcome by using certain relationships, we looked at regressions. For this week and pretty much all the weeks after exam 2, we're dealing with a parametric dependent variable and a non-parametric independent variable. So that's this section here of our flowchart. And the non-parametric variable, remember, would be a nominal variable for the case in this class. When we look at how many independent variables we have, for a t-test, it will only be one. And then that particular independent variable will only have 2 levels or categories that the independent variable can be split up into. So you could think of this as a pre-test and a post-test. You could think of it as some type of therapy intervention and a control group, males versus females if you're comparing 2 different sports. But in either case, whatever the independent variable is, it's only split up into 2 categories. From there, we have to investigate what type of sample we have collected for each of those categories, right? Have we used the same people twice? So same people being measured in each category, which would be a within subject variable. Or have we measured independent samples where we're collecting different people for each of our samples that we're going to compare to each other, which would be a between subject variable. In the case of a between subject variable, that would lead us to run an independent t-test. And when we have a within subject variable, that would lead us to run a paired samples t-test, which is also known as a dependent t-test. So just to look at this in a different light without all of the other stuff in our decision tree, right, we're looking at a parametric or ratio or interval dependent variable, only one. We're going to have a non-parametric independent variable, again, just one, and it's going to be split into 2 levels. When we have 3 or more levels, that's when we go into ANOVAs, and those will be what we focus on for the last kind of section of our class. So we're not worrying about those just yet. Once we figure out that our independent variable has been split into 2 levels, we can see which type of independent variable or how we've collected that independent variable in terms of our samples. So independent samples would be a between subject, which again would lead us to an independent t-test. The same measures or repeated measures or within subject variable would lead us to a paired samples t-test, again also called a dependent t-test. The goal of a t-test is going to be where we start looking at cause and effect type, and I don't want to say relationships, but we look at really how the manipulation of an independent variable causes or affects an outcome of a dependent variable. So typically in a t-test, again, we're going to be examining the difference between 2 means. So that means we take a bunch of data that we collect on a certain outcome variable, we take the mean of that data for each group, and then we compare the means of the groups together to see how different they actually are. Statistical difference between means is going to be evaluated by something called the t-statistic. We calculate this by looking at the mean difference, right? So I have x bar sub 1, which might be the mean of one sample, and we look at that difference with the mean of another sample. And then we divide that by the standard error of the mean difference. There are different ways to calculate this. We're not going to go into that for this class. Usually SPSS will provide you with the standard error of the difference, so you should be able to calculate the t statistic just using the information that you're given in your output. T is also calculated for you in SPSS, but there will be instances in the activity where I ask you to calculate t by hand, and then we'll end up comparing that t value to a table, which provides us a different way to kind of figure out what significance we have in terms of the difference between the means. So calculating t, we're going to use the raw data, right, by looking at difference between our means and the standard error. And again, the difference between the means can either be between or within subjects. So this formula, if you will, doesn't change whether you're looking at a between or within subject comparison. For our null hypothesis, typically your research question is going to be investigating, again, a two-level independent variable to see if that intervention that you're applying has a significant effect on the dependent variable outcome. So our non-directional or two-tailed hypotheses for a t-test, the null hypothesis will say that the independent variable has no significant effect on the dependent variable. In other words, the means of each sample are equal to each other, or relatively equal to each other. The research hypothesis will argue the exact opposite, and it will say that the independent variable has a significant effect on the dependent variable. In other words, there is some difference, right? We're not indicating if we have one mean that's above or below. Rather, we're just interested in, are they equal or are they not equal? So the research hypothesis would argue that the means are not equal to each other. I have other null hypothesis variations in the notes section of the PowerPoint version of the lecture. So other ways that we can say this yellow null hypothesis here is there is no significant difference in the dependent variable between the means of sample A and B, or sample 1 and 2, right? We could also say the mean of whatever our dependent variable is of sample A is not significantly different from the mean of sample B. So many different ways that you can articulate the null hypothesis, as well as your interpretations of p-values as they relate to the null hypothesis. I think writing it this way is the easiest, but feel free to write your interpretations and your nulls however they make the most sense to you. So once we have our null hypothesis, we run our statistical analysis, which again we'll go through how we set up the test and the output in the next video. And then once we get all of that in our output, we get a p-value for our t-test. Now remember, the main effect of our t-test is saying, do we have a significant difference between two means? When we determine p, we can either estimate p-values, so that's where we would calculate a t statistic and then compare it to values on a t-table, which I'll show you in the next slide. Or we can get exact p-values, which are going to be provided for us in SPSS. So again, I'll show you guys those in the next video. As far as the evaluation of p, it's fairly similar to what we've been doing for this semester so far. So if p for our main effect, or for our t-test, is greater than alpha, which in our case is usually going to be 0.05, right? That indicates that we should accept the null hypothesis, because there's likely a large chance that there could have been type 1 error, or that the effects of our intervention weren't that strong enough to change the mean of the experimental group. Right, so in this case, if p is larger than alpha, we accept the null hypothesis and argue that the independent variable has no significant effect on the dependent variable. In the other case, if p is less than alpha, then we reject the null hypothesis and say that there is a significant effect of the independent variable on the dependent variable. When we use the t-table, so this is when we're estimating p-values for the difference between two means, this is the table that I have given you guys in Beachboard this week, and there's a couple of different ways that you can go about reading it. So the different components of the things that you need to know before you use the table is the level of confidence and or your alpha. We know if you know level of confidence, you know alpha. If you know alpha, you know your level of confidence. So it's kind of like if you know one, you're pretty much good to go. The level of confidence is indicated at the bottom of the table, whereas alpha is indicated at the top. You'll see the cumulative probability listed here. I feel like sometimes this might confuse students. So I usually say just look at the confidence interval. We're always going to be using two-tailed tests. So like if you keep your eye on the two-tailed test and you say, oh, I want to see like I have an alpha of 0.05, this would be the column that you'd be interested in. Alternatively, if you know an alpha of 0.05 is associated with a 95% level of confidence, you could also just look at 95 at the bottom and know that this is also the column that you're interested in looking at. We will do some examples for t-tests when we're estimating p-values that will look also at the 90 and the 99% columns. So for this, at least for estimating p-values, it's not always going to be that alpha is equal to 0.05, but for SPSS, you can for sure know that our alpha is always going to be 0.05. So estimating, we have a little bit of flexibility. Exact percentiles, we're always comparing to 0.05. The other thing we need to know is the degrees of freedom, which are indicated by the first column in the table. And though I have an asterisk here because we're going to discuss how you do degrees of freedom on the next slide. It differs between independent and paired sample t-tests because of how we collect samples. But generally the rule of thumb is n, which is your sample size, minus the number of samples that you've collected. The values in the actual table, so the rest of the space that we haven't discussed yet, are our critical values of t. Now, a critical value is basically telling us the value of the t statistic needed to argue a significant difference between two means. So back a few slides ago, I showed you guys how you would calculate t, right? And then we take that calculated t, figure out like if we have a 95% level of confidence, and let's say we ended up deciding that our degrees of freedom was 15. This value here, I know it's kind of small, but 2.131 would be how large t has to be in order for p to be less than 0.05 in this particular instance on our table. So if we calculated a t of 2, right, just 2.000, that would be less than our critical value, meaning we didn't have a large of enough difference to argue that we have significance. So if t is less than our critical value, p will be greater than alpha, right, indicating no significant difference between our means. Let's say, though, that we had a t, use our raw data, we calculated a t of 2.5. That's greater than our critical value, meaning that our difference between our means was large enough to say that we have a significant difference. So in that case, if t is greater than our critical value, then p would be less than alpha, indicating we have a significant difference between our means. For our degrees of freedom, again, it's the general rule of thumb is the sample size minus the number of samples you've collected. For an independent samples t-test, this is when we have two independent samples, meaning we've collected one group of people, and those people are different from another sample that we've collected. So one might be a control group, one might be an experimental group, and then we're interested in comparing the outcomes of those two groups, right? But in this case, we have two samples, so we would take our total sample size and subtract 2 because of those two samples. So that would be for an independent t-test. For a paired samples t-test, we've technically only collected one sample and we're just measuring them twice. So degrees of freedom for a paired samples t-test is going to be the total number of individuals that we've collected, or our total sample size, minus 1 to represent one repeated sample.